Today we're going to look at two different ideas, one called functions, one called inequalities. We're going to start with inequalities because they are very similar to equations, which is the last topic we looked at. And again, as I've been saying before, these are going to come back in 7th grade. Here we go. So find the solution to each inequality. Well, you know me by this point, so the first step would probably be to rewrite it. X plus 12 is greater than 15. All right, so sort of like an equation, we're going to put a wall through the symbol of inequality, and then we're going to solve it sort of in a similar way. So what's the inverse of the opposite of plus 12? It'd be minus 12. So we're going to do that on both sides. Plus 12 minus 12, those cancel out. Now this is, people are kind of mixed this last step up here a little bit. So a lot of people will bring an equal sign down here, but this is not an equal sign. We're going to use the greater than symbol. So we're going to keep the symbol that we started with. And then 15 minus 12 is 3. So any number x greater than 3 will work for that inequality. We can't check it because an infinite number of numbers would work. So we're not going to go through and check each individual number. All right, let's check out the one right next to it here. We got x minus 8 is less than or equal to 16. Same type of deal here. We're going to put the wall right through it. I thought I was going to use red for that, but maybe I'll make that red here. Let me try to trace that over just to make it pop a little bit more in color. Nice. All right, how do we get rid of minus 8? Well, we're going to do the inverse, the opposite. We're going to add 8 to both sides. I think this has been on Throwback Thursday a few times too, so we will have seen this more recently. Minus 8 plus 8, those cancel out, and you're left with x is less than or equal to 16 plus 8 is 24. 24. So any number x is less than or equal to 24 would work for that inequality. Let's try this one. 4 times x. I like to put that dot in there just because it reminds me that it's multiplication. 4 times x is greater than or equal to 48. Okay, let's put the wall in there. How do we get rid of times 4? The opposite of times 4 is divide by 4 on both sides. The 4's will cancel out, and we're left with x is greater than or equal to 48 divided by 4. Well, 40 divided by 4 is 10. 8 divided by 4 is 12. So it would be, or 2 would be 12. Any number where x is greater than 12 would work for that inequality. All right, last one of these type, and this is we're gonna write it in a different way. It says x divided by 7, but we're gonna write it like a fraction. X divided by 7 has to be less than 84. Let's put the wall in there. How do we get rid of divide by 7? Well, we're going to multiply by 7 on both sides. Inverse. 7 and 7 cancel out, and x is going to be less than, well, I don't know that off the top of my head. So 84 times 7. Again, you'll be able to use the calculator on the test, as I've said before. 7 times 8 is 56, plus 2 is 58. So it looks like we get 588. X has to be less than 588 for that to be true. So anything less than that. 0 would work. 0 minus 7 is 0, which is less than 84, so that would work. All right, let's check out another part of inequalities, which would be graphing an inequality. And just remember, when we have a less than or greater than symbol, here's greater than, here's less than, we're going to have an open dot. Kind of looks like a yelling face there. Okay? When we have a less than or equal to, or a greater than or equal to, we're going to have a closed dot. It's kind of like a yawn, like a yawny face. So less than or equal to, you got the bags under the eyes, it looks like. You're yawning. That's a closed circle. If we don't have the or equal to's, it's going to be an open dot there. All right, y is greater than 5. So we're going to start with 5 in the middle. We can do maybe like 3 on each side. I'm not going to number this entire number line just for the sake of time, but you could if you wanted to. All right, so to do this, we would think about what kind of dot would we put at the 5, because that's where we're kind of like starting our thinking about this inequalities at the 5. Y is to be greater than 5, but not equal to 5. Since it's not equal to 5, oh boy, we're going to put a circle here. Okay, I'm back. I just had a special guess there. So we have an open dot on 5 because it's not or equal to, it's just greater. So because it's greater to, we know where the arrow is going to go. I'm going to try to use a line for this. So it's going to go to the right. And we're going to put an arrowhead at the end. I'm going to make that line a little thicker so you can see it better. There we go. There it is. Okay. Next. Y is less than or equal to 10. I know it's less than because it kind of looks like an L, like a little L that's kind of like flattened out a little bit. So that's how I can tell. If it looks like an L, less than. So we're going to start with 10 in the middle. 11, 12, 13, 9, 8, 7. We're going to have a closed dot because it's or equal to. It includes the 10, and it's less than or equal to. So we're going to be going in the less than direction. Less than. Or equal to. Whoop. All right, next we got y is less than 3. Y is less than 3. We're going to start with 3 in the middle. 2, 1, 0. And then 4, 5, 6. Okay, so open or close? Well, it's less than. I know it's less than because it looks kind of like an L. And it's open because it doesn't include 3. It's y is anything less than 3. So I'm leaving it open. And then we're going less than 3. So we're going this way. And there it is. Okay, next question is a little bit more related to functions. We're going to be writing ordered pairs, which are like an input-output. So it says Franklin earns $6 for every lawn he mows. It's not a lot, but you know what? That's enough. The equation t equals 6 times m can be used to find t, the total amount Franklin earns after mowing m lawns. Write a set of ordered pairs to represent the relationship between the number of lawns he mows and the money he earns. Well, if he mows one lawn, he has made $6. I know that not only from the problem, but from the equation. The total money he earns is however many lawns he mowed times 6. 1 times 6 is 6. 2 times 6 is 12. 3 times 6 is 18. And 4 times 6 is 24. Now we're almost done, but in the ordered pair, I know that variables are different, but this is kind of like the output, which is x. Lawns mowed is kind of like the output. I'm sorry, it's the input. Money earned is kind of like the output, which is going to be the y. So we're going from x to y, from input to output. So when you write an ordered pair, even if the variables are different, x is going to be the first number, which is the input. Y is going to be the second number, which is the output. So we have x, y like this. X is the input, y is the output. So for the first one, the input was 1, the output was 6. So our ordered pair is going to be 1, 6. And then 2, 12 is our next ordered pair, input, output. 3, 18, input, output. 4, 24, input, output. There it is, x, y. Now we could go ahead and graph those, but we don't have a graph to graph them on, so we'll just leave them as that. But that's what an ordered pair might look like, and we can get an ordered pair from looking at the input and the output in that order. Okay, last couple problems here. These are a little tricky. There's one like this on the final exam. This is why we're doing a couple here. But these could be tricky for some people. It says, for each graph, make a function table for the input and output, then write an equation that you can use to find the relationship between the inputs and outputs. Okay. Well, remember, the output is kind of like the total. So if we think of the output kind of like the total, that might help us write the equation at the end. Well, if we look at our first point on the coordinate plane, days, which is the input, this is always the input because it's on the x-axis, and money spent would be the output, it's on the y-axis. So the first input is 1, and the first output would be 5. On one day, you would spend $5. 2 days would be 10. 2 days, you'd spend $10. 3 days, you'd spend $15. And 4 days would be $20. So let's think about what's happening here. Y is the total. And you can see it right here too. Y is the total money spent. So Y, the total, is going to be by itself. I'll just draw another arrow there. How do you find the total? Well, you take the input, which is X, and what do you multiply it by? It looks like every time you're multiplying it by 5. And we can see that too right here. These numbers are going up by 5. That means we're going to multiply by 5. So we're going to do X times 5, and that will give us the equation. Let's just check that real quick. If X is 1, 1 times 5, the output would be 5. If X was 3, 3 times 5, output would be 15. So it looks like that equation would work for that particular function. This one's a little trickier. Here we go. All right, so the input is number of classes. I'm going to put an X right there. That's the number of classes. The output is, oh, look at that, total change. There's the output, which is Y. So there's the total. This is going to be the total. Okay, so if we look, our first input, I know it's kind of on the corner there, but 0 classes. How much do you charge? It looks like you charge $30 for 0 classes. We actually did this one earlier a few months ago, and we found that $30, even though you do 0 classes, you still have to pay like a membership fee to go to this gym. So that's where that 30 comes from. You do 1 class, and it appears to be around 38, 39. We'll go with 38. 2 classes, be like 46. 3 classes would be 54. All right, let's check to see how these numbers changed and how we can write our equation. Well, the total goes by itself, and in this case, the total is Y, as it was in the last one. So the total is Y, so total charge, that's the output. And how do we get the total? Well, we take the number of classes, which is X. Let's see what we multiply by. Now, again, you can always figure out what we multiply by looking at how the output changes. Appears to be going up by 8, which means that we would multiply by 8. But this is not the entire equation because 0 times X is not, 0 times 8 is not 30. 0 times 8 is 0. 1 times 8 is just 8. 2 times 8 is 16. So we're not getting to the number we need to get to. So we might need to add on. Well, or subtract, depending. But it looks like we're adding on because 0 times 8 is 0. How do we get to 30? Probably plus 30. 1 times 8 is 8. Plus 30 is 38. 2 times 8 is 16. Plus 30 is 46. So notice I'm checking them to make sure it works for all numbers. 3 times 8 is 24. Plus 30 is 54. So that checks out. So finding a function rule, that can be difficult, but looking at how the output changes can tell you what to multiply by, which will be helpful in finding either a rule or an equation. Well, if you have any questions about functions, let me know, or inequalities. Hopefully some of this has come back to your memory a little bit from earlier in the year. If you have any questions, please let me know. If not, I hope you have a great day, and I will see you soon. Okay, bye-bye.